Hi, I'm Ed Amoroso from Tag Cyber, and I'm here with John Loucaides, who is the Vice President of R&D at Eclypsium. John, how you doing?
Pretty good. How are you?
I'm looking forward to talking to you today about firmware vulnerabilities and some really interesting supply chain issues I know you're working on. But why don't you start? Maybe tell us just briefly about the company, and then we can get into the deeper discussion.
Eclypsium was founded around the idea of what we call defending the foundation of all of the enterprise infrastructure. And so, what is the foundation of every computer device? It's really firmware and hardware. The thing that actually makes all of that stuff we do happen. And it's this huge attack surface that's usually overlooked. I personally got interested in it a few years ago, and when I met our founders, we started working in that space as researchers, and from there we started eventually figuring out that this is a whole area that's just been untouched, untapped by the security industry, and we wanted to change that. It turns out that attackers go deeper and deeper into the platform over time, especially as they do meet with resistance from actually effective security technologies. So really, in a funny way, the most advanced security systems are the ones that are most vulnerable to this sort of attack. And this is the sort of thing that really makes, I mean, a lot of researchers like myself very interested. And
Yeah.
so here we are.
Well, when you say foundational, you mean foundational. You're talking about
Oh yeah.
hardware, firmware. So that's fun.
You build up this whole stack and you have assumptions on everything below you. Um, when I started out, I was working for the US government doing security evaluations on what they would call high assurance systems. And these high assurance systems usually would have formal methods or very tightly controlled requirements and implementations just around the idea of preserving particular properties. And I got interested in this space because the way to break those maybe formally proven systems is to violate their assumptions. And you violate assumptions when you break something down at firmware and hardware layers.
So interesting. I actually did my PhD in that area. I used to use these
Oh,
formal
really?
verification systems to prove properties. And I guess firmware is one of the few places maybe where you have a shot of being able to do something, halfway meaningful. But you guys take it way further. Let me ask, let's start with a little bit about maybe some of the vulnerabilities,
Hmm.
and then we can get into the technology. So what if I'm a CISO and I'm listening to you and I talk? Why,
Yeah.
why do I care about the firmware? I would think, you buy your computer somewhere, they come in, and what should I be worried about at that level? That seems so remote.
One of the things that in the position of maybe a CISO, you've probably actually already experienced some of these firmware attacks or firmware issues at the very least, and that's in the form of a lot of your network equipment. And this year in particular, and really it's been on its way up for the last few, all of these network device vulnerabilities are actually getting exploited. And it's been an area of, again, this sort of latent code, this huge attack surface that mostly just is invisible. It's not being the subject of a lot of attention until now, when you're actually seeing a lot of not only APT groups, but now that the exploits are pretty widely known, you're seeing a lot of groups actually target your VPN, whether that's the some of the Cisco stuff, some of the Systrix stuff. There was a top 25 report recently released, huge amounts of this just in network equipment alone. But the thing is that network equipment and the thing that you're seeing there is not unique. You have the exact same thing on every computer, whether it's a desktop or laptop or server. And so what we're trying to do at Eclypsium is to really get a pervasive handle on that, not just on one model or one series or one version. We're actually going to try and go across the whole enterprise and really get at what we think of as a profile for those devices and discover when they're being attacked and when they're vulnerable.
Now, help me with the attack model a little bit. I'm trying to think if I were going to target firmware, how do I go after, like, am I opening a command line interface? Is it in the operating system somewhere? Like, how do I change firmware? How would malware go about doing that? What's the entry point?
I'm super glad you asked that question. It turns out that this is an area that a lot of people don't really understand, and they think of firmware as something that's almost physical. And so I need to open up the computer and mess around with it in order to do that. And you're not wrong. You certainly can get at firmware that way. That's maybe the most obvious way to go after firmware. But the thing to remember is that firmware is what's making all those other components within your computer actually work the way you think they do. When you go and send packets out of the network card, well, how do you think that network card is operating? It has to be configured down at a firmware level in order to actually send in the way that you expect it to send, with this MAC address and with this with these protocols being offloaded into hardware. So what ends up happening is that if you can break or somehow change firmware, you change those properties of the system. The system itself has an interface to change firmware as well. And the operating system usually has some support for that, but you probably haven't heard about it, because the only time you ever end up using this is when you're updating some firmware to uh, to fix some bug. Usually, it's maybe a reliability problem or performance problem, and that's where you can sneak in as an attacker and actually break some bit of that interface inside the box. That's why it's both a physical attack and a software attack.
Now, how does your platform work? Are you climbing in the middle of that somehow? Are you monitoring? What do you guys do? What does the Eclypsium software do?
It actually bases all of this monitoring. It's basically a telemetry platform that
Hmm.
monitors what's going on down at this level, and we use the fact. See, we use the fact that those interfaces exist and that those interfaces are sort of uncommon for most people, because what this means is we can scan that and we don't actually affect anything else that's going on the platform. We're looking down at this firmware interface that other people aren't really using, other than when the system boots as part of initialization, and then they sort of leave it alone. We can actually do that, and you can be using your computer normally and won't even notice that we're there. Another thing that we're doing is this is pervasive. This is a software interface. So when I was working for the government, we would do a lot of mitigations to these sort of attacks down at a physical layer by actually inspecting specific things on boards. And and that just doesn't scale very well. As a software tool, we're able to pull all of this back and automatically identify deviations from a profile. That means even if I've never seen an attack before, it's totally unique, maybe it's very targeted, I'm still going to detect it. Does that make any sense?
How do you? It does. How do you build a profile? Do you have to collect behavior analytic data first, or is it aggregated right out of the box? Well, how do you know what's normal?
So that's a great question. One of the things that happens all the time in Eclypsium is for us to be expanding our profile building. And
Hmm.
so if you come out with a new model of a computer or maybe even a new firmware version, it takes a little bit of time for us to go grab whatever we can about that and infer from the manufacturer and the things that they've released what's normal. From there we can actually tailor it. So this is where Eclypsium creates what you might think of as a global reputation, and you can also have a tailored policy for your organization. Say that you actually have custom firmware that other people don't have. In that case, you customize this and you actually say, whatever Eclypsium has seen, I don't want that on my stuff. I want my custom version, and this is the only version that's ever approved. And you can lock down these policies that way. Same idea with configurations and behaviors. And so if the system starts behaving in a way that is normal in a sense, because it's possible for you to have configured it that way, but you in your environment never use that feature, then we can alert on that. A good example is actually what happened with the Platinum campaign. You have an out of band management interface in the form of Intel active management technology. It lets you send packets out through a different method than the OS would usually use. And that's how this malware was using their command and control. And so the idea is that it's just a feature that was being abused by the adversary. And we would detect it because it's outside of the profile for your organization.
Now, where does all this run, and where's the administrative interface and so on? I presume are you using cloud for some of
Yes,
this?
sure.
How
In
does that
fact,
work?
well, so what you're going to do is there's two sort of components. There's what I might think of as the scanner, the thing that's going to go and poke at all of those hardware and firmware interfaces, and it's going to start building what I would call a scan, not necessarily the whole device profile, because that's just one snapshot in time. And you're going to build that up over time to build a profile. And then you're going to send it to what we call an analytics server or backend. That could be in the cloud. And so the easy way to just deploy this is to just run this scanner across a bunch of systems, have it send that data back to the cloud for analysis, and then you're just going to start seeing here are the vulnerabilities, here are the integrity failures that the system isn't operating within that profile that we expect. And you can actually take that and set up alerts so that you don't ever have to go through this user interface and go through all of the machines. You actually just get flagged into your SIM whenever there's a deviation that's unexpected.
What's been your experience with enterprise teams patching firmware? Is this one of the big neglected areas? It seems like it probably is, but I'm curious what you think.
It certainly is, but I wouldn't look at this the way that sometimes patching has a reputation of it's like um, going to the doctor or the dentist, and you know you have to do it, but you never really want to.
Mundane routine thing.
Yeah,
Yeah.
so I don't think of firmware patching quite the same way. It is often very different for real reasons, and there are good reasons why organizations don't just turn on automatic updates for firmware. Um, but I think the problem is that we end up in the other extreme where we just forget about it and it sort of gets neglected.
Mhm.
And one of the problems with that is that you don't actually know the properties of that firmware that you may or may not want to update. So, for example, um, we can find on a lot of firmware images a vulnerability in the TPM where the TPM firmware has not been updated and the TPM will not generate secure RSA keys. Well, that's an interesting problem that could have massive ramifications if you actually depend on that. Now, if you're not using it, you don't care, but that's the point. You need to know that specific component, that specific firmware, and how you use it before you can really make an intelligent risk decision in this
Yeah.
in this context. And because you're not seeing this information, because normal methods of managing large infrastructure, they just don't look there, you don't have a lot of hope of actually doing anything with it unless you start increasing visibility. So that's kind of Eclypsium's first mission is just the visibility of this layer, if that makes sense.
It does. I'm curious, as you're talking, it's a lot of this sort of screams application to procurement and supply chain teams, working
Absolutely.
legacy and so on. Does that come up in your discussions with clients? What's the supply chain angle here?
Absolutely, it does. We actually have this new NIST actually announced a
Oh,
new
okay.
program for supply chain integrity. And we're one of the collaborators that's part of that activity. And
You
what
mean that's not an oxymoron? I'm sorry, I couldn't read that.
it's kind of a fun thing because you get an organization like NIST trying to bring together industry, and that's kind of
Yeah,
cool.
they usually do a good job with that. So
Yeah, and what's fun about what they're doing is that they're taking a different slant on what's going on with supply chain than a lot of things that I've seen before. A lot of the previous work that I see in supply chain is very procedural. It's looking at the policies and procedures of the suppliers to your organization and whether or not they have those certain things in place. And that's a really good thing to do, but it's not a strictly technical thing. It's missing the actual looking at the product and whether or not it's good, whatever that means. And that's why it's hard. So, this is actually what the NIST project is doing. They're actually working with the manufacturers, and the manufacturers are going to build in some bits and pieces that will allow you to check something. And then you're going to have a point in time where you check it. And then you can check it continuously in operations and recheck it and see if it's been tampered with. And all those things are kind of cool. And Eclypsium fits right into that in this wonderful way where we try to be not based on a single method or single technology. So we will use the manufacturer's bill of materials, the manufacturer's signing. They may have signed different bits and pieces of firmware. We'll check those things. We might use the TPM, pull that in. But what we add on top of that is a direct observation of the behaviors of the system, of the integrity of what's there. And we do this through multiple interfaces down at that level so that we can create the whole package. And that's what I think is going to be particularly interesting going forward. I've had some discussions with some customers about building that into the actual acquisition life cycle so that when you first provision a machine, you take it out of the box and you actually run our scan as part of the provisioning process. Again, you don't even have to add something new to your set of procedures. It's just part of that same script. Um, it will start building that profile immediately
Wow,
out of the box.
that is cool. Now, who normally are you selling to? You sell to the security teams, to the IT teams, to both? Seems like you're in that seam between the IT operations folks and the security people. What's
That
been
is
your
the tough part,
experience?
actually.
Mm,
Oftentimes, it's a little of both. We usually lean more heavily towards the security sort of endpoint team
yeah,
because we speak a lot of security language.
yeah,
But let
sure.
me let, let me tell you something interesting about what we're doing. If you were in more of a data center or hyperscaler sort of situation,
Oh
you
yeah.
would do the same thing we're doing, but you would call it observability, and it would be a reliability engineering type visibility tool. And that has a lot to offer that we can unpack as we sort of work with our customers. I think that the core of it is really this idea of a profile. You look at the profile and you can decide there are risks associated with being in this profile. And that could be security risks, but that could also be reliability operational risks. And I think that's going to be an interesting thing as we go forward.
That is interesting. That's I guess not surprising given the work that you guys are doing. Hey, let me ask you to take out your crystal ball here. We're knocking on the door of 2021 here as we film this video.
Yeah,
What do you see coming? You're in R&D. The R part stands for future. So,
indeed.
what do you think? What do you see coming in this area?
One of the things that I've been seeing for a while, and I would project that this trend kind of continues, is that attackers are moving lower and lower in the stack.
Oh
And you
yeah.
can you can see that. Like I'm not really going out on a limb with that one because there are a lot of examples where you've added a lot of protection mechanisms into web browsers and all of your document readers and all of your operating systems, and what you're going to end up finding is that if you try to invest the next, however many months for the good set of exploits that are reliable, you're going to have to do a bunch more work to do it up at this level than you will at the firmware level. And I think that's already started to show. We saw LoJax previously. This year we saw Mosaic Regressor, and I'm going to bet that there's going to be another one within the next couple of months. Because the reality is that this stuff gets reused. And what you found is in both of those cases, it's really a reuse of existing code that's already out there. The time of firmware security being this obscure thing that you need an expert to figure out is kind of over now.
Mhm.
There's enough out there that this is going to become bigger and bigger as those sets of codes get developed and propagated around and reused in different campaigns. And that's what I think we're seeing now. If you look elsewhere outside of that sort of exploitation space, I think you're also going to see something interesting happening on that reliability front, where this idea of what others would call observability, where you can sort of create a profile and start to see a machine that's misbehaving, is going to also be a big deal outside of just the security envelope, but also the area of being able to handle resilient operations, especially remotely, like we all are these days.
Now, John, for people who are interested in hearing more about Eclypsium or being in touch with you guys, is the website the best place, or what would be the easiest way for them to get information about the company?
Certainly, you can get all sorts of things on the website, but don't be shy about reaching out to us. I think, in a way, we can put all sorts of good information out there in a generic fashion, but usually the best stuff comes from actually talking to people one on one, individually, or in groups. And you usually end up having a specific little curveball that you want to throw at this, and that's okay because the thing is, we've we've been working in firmware, right? There's a lot of curveballs over there, and we're pretty used to it. It would probably be best to just have a little discussion. And then you can understand the ins and outs of your environment and how it would work.
As we have done over the last 20 minutes or so. I totally
Exactly.
agree. I think the interaction is valuable. Well, John, on behalf of the folks watching and our team at Tag Cyber, I really want to thank you. I always enjoy connecting up. You do such fine work.
Thank you.
Hope things are going well for you, and
Al-
we appreciate you spending time.
Always great to chat with you. Thanks again.
That's good. And for everyone watching, we'll see you next time.